Welcome back, students. In the last two videos, we saw in detail about VI graphs. We understood that a steep slope reflects higher resistance and a flatter slope reflects lower resistance. Kindly visit my past two videos to understand this video better. Now, what we are going to say is something different or opposite to what we saw in the VI graph. So now, instead of the x and y axis values change, like IV graph, where currently in VI graph you have current in the x-axis and voltage in the y-axis. Whereas in IV graph, you have just the reverse of whatever we said so far. Basically, both are correct. VA graphs are more common in textbooks and IV graph is less commonly used. But in your exam problems, sometimes IV graphs are given. So it is better to understand the IV graphs as well. Basically, it's nothing but the position of the steeper and flatter slope gets ulta or reversed. So let us see how it is. See, for a IV graph, you see voltage here and current here. So the slope is y by x, value of slope is y by x, y is nothing but current, delta current divided by delta voltage, delta voltage, which is basically nothing but reverse of resistance. So resistance formula is R is equal to V by I. When you have I by V, it is nothing but 1 by R. So the slope of a IV graph gives you the inverse of resistance. So the two videos prior to this, we tried to plot the VA graph where we had current in the x-axis and 1 minute. We had current in the x-axis and voltage in the y-axis. We took two hypothetical scenarios where resistance was R is equal to 2. The resistance was 1 by 3, which is but 0.67. 2 is the one with higher resistance. You can see the steep resistance here. And 1 by 3 is the lower resistance, which has a flatter curve. Now, when I reverse this chart, what you see here is the two voltage comes in the x-axis and current goes in the y-axis. The value of 2 you can see as a flatter curve. The higher resistance line comes flatter and the lower resistance line becomes steeper. So what I would suggest is you always remember well the VA graph, and should you come across IV graph, just reverse the logic. You keep remembering the concept related to a VA graph itself, like steeper is higher resistance, flatter is lower resistance. And if you get a problem and if it's a VA graph, solve this way. Suppose should you get a IV graph, you are just going to invert the logic. Now flatter becomes higher resistance and steeper becomes lower resistance. No need to dedicate a separate understanding for this. You just need to reverse the logic. So now moving on to the next topic, non-ohmic materials. See, in this graph, if you see, it is not a straight line. It is changing for every few values of current. This is when the resistance increase when the current and voltage increases. When the current is 1 amperes, you have a 1 resistance value. When you increase it to 2 amperes, the resistance increases and the graph takes a little different path. And when the current is 3, again the resistance increases and the graph changes. And sometimes resistance increase with increase in temperature. So if the graph is not in a straight line, it is called as non-ohmic materials, which means it doesn't obey the Ohm's law. So if you are given a graph something like this, you should understand that it is a graph pertaining to non-ohmic materials. So what are the limitations of Ohm's law? See, Ohm's law, we saw voltage and current are inversely proportional. The proportionality relationship comes from the resistance. It's a straight line and goes through the zero or the origin. What are the limitations? See, as we saw in our previous slide, it is not applicable to non-ohmic materials where resistance changes with current and voltage. So graph is not a straight line. Again, Ohm's law is valid, temperature change. Again, Ohm's law is valid only when the temperatures are constant. When the temperature starts varying, the resistance changes, which affects the current flow. So Ohm's law is valid only for constant temperatures. Lastly, the limitation is high and low resistance. You have extremes, two extremes. One is zero resistance. Absolutely, there is no resistance to flow of current. Those are called as superconductors. And insulators, which completely block every current, means you don't have any current flow. So these are the two extreme conditions where Ohm's law will not be applicable. Extreme conditions of high and low resistance, Ohm's law is not applicable. So in the next video, we'll solve some board problems, or probably we'll complete the textbook. We have one more minor topic, that is the heating effect of current. We'll complete it and then go to the board problems. Bye and thank you till then.